In this question, and I'm going to start off talking about this one right here, we're asked, if you have this point P, right, there's the x-coordinate, y-coordinate, radical 3 over 2, negative 1/2. Suppose you have this point P on the terminal side of an angle in the standard coordinate plane. It wants to know what is the reference angle in degrees. Okay, so I've pasted the unit circle to the right. You can see this guy over here, and super useful. I hope you have it memorized by now, but let's just use it anyway. Where is that point? Root 3 over 2 and negative 1/2. Well, if you look around, I know this is a positive x value and a negative y value, so that should lead me pretty quickly to the fourth quadrant. And here we go. This is my point right here. Let's use something really thick to mark it. Okay, I'm going to use Riverton purple. There's my point. Okay, x equals radical 3 over 2, y equals negative 1/2. So we're talking about the angle 330 degrees. And if you remember what reference angles are, okay, reference angles are, let me draw a little schematic of quadrant 4. Okay, here's an angle in quadrant 4. There's theta, right? In this case, that's 330 degrees. Reference angles are the angle, the shortest angle, smallest angle between the terminal side and the x-axis. So in this case, that's just going to be the remainder, 30 degrees. That's how far it takes you to get to a full circle. So my answer for this one would be 30 degrees. Now I've pasted another version of this question below, down here. I want to talk about that one, because if you tried the same technique that I just outlined for the first question, it's not going to work. And the reason is, go ahead and try to find this point. Negative 4 root 2 comma 4 root 2. Where is that on the unit circle? Well, it's not, because the x value and the y value both have magnitudes greater than 1, which means the radius is greater than 1, which means it's not a unit circle anymore. It's like something bigger than a unit circle. So we need an alternate way to solve this problem. And once we go through this alternate way, you could go back and solve the original problem, right, the easy version, using the same technique. I wouldn't bother, but let's try and figure this out. Take a look at that coordinate again. Okay, negative 4 radical 2 and 4 radical 2. Okay, so what that's saying is negative x and positive y. So let's draw ourselves a standard coordinate plane with a triangle in it. Okay, that's always a good place to start. What would this triangle look like? Let's make it nice and big. Negative x, positive y. That's going to look like this. Okay, there's my negative x, and positive y is going up this way. So here's a triangle in quadrant 2. Okay, and the point that we're told, P, is going to be right here. So that's negative 4 root 2 comma 4 root 2. So there's my point. And just like before, it's useful if you label the sides of this triangle. You can use the x-coordinate to label the x side. That's right here, negative 4 root 2. And the y-coordinate to label the y side, positive 4 root 2. Here's my angle, theta. And the reference angle that I'm looking for, remember what a reference angle is in quadrant 2? It's how far you have to go before you reach the x-axis again, the shortest distance to the x-axis. So there's my reference angle. Now, how do I figure that out? Because I can't use the unit circle. Clearly, I'm way off the unit circle. Let's go back to trig properties. These are our basic ones. And I'm just going to pick on tangent. The tangent of that reference angle. What is that? That's opposite over adjacent, right? SOHCAHTOA. And opposite is 4 radical 2, and adjacent is negative 4 radical 2. And you see most of this stuff is going to cancel out, and we get negative 1. So here's my question. Where is the tangent of an angle equal to negative 1? Go back to your unit circle. You should have these memorized, but let's just point these out real quick. That point G is where tangent equals negative 1. And we also have this point down here where tangent equals negative 1, but we know we're not in quadrant 4, so that one actually doesn't matter. I'm looking at the angle 135 degrees. Okay, so that just told us that theta equals 135 degrees, and this blue angle, reference angle, you can see that's going to have to be 45 degrees. It's the difference between 180 and 135. So that's the steps you go through to solve this one. You have to free yourself from the unit circle and start thinking just in terms of triangles on coordinate grids. And then use some of the trig properties to figure out what tangent is, or what sine is, what cosine is, whatever is useful for the condition you're looking at.